For our last day of notes for 7.5, we're going to start using these proportional relationships, okay? And we're going to use them when it comes to perimeter and area. Okay, so let's start with a little bit of a warm-up. Find the following ratios given that the triangles are similar. Okay, so we're going to be using triangle ABC is similar to triangle DEF. So AB, we're going to find that length. AB is 5. So that's going to go on the top. And DE is going to be 10. Okay. Now if we type this into our calculator and we do 5 divided by 10 and then we use our buttons to convert this into a simplified fraction, it'll give us 1/2. Okay. And then that is our ratio, 1 to 2. Now let's work on BC. BC, connect those two letters, is 3. EF, connect those two letters, is 6. Again, type 3 divided by 6 into our calculator, and it will simplify to 1/2. So far, we're doing good that we know these are similar because those are the same. Now let's check this last one. AC is 4. DF is 8. Simplify it to get 1/2. Okay, so when we have all of these ratios, okay, the perimeter ratio is going to be the perimeter of ABC over the perimeter of DEF. Well, if we do that, it would be 5 plus 3 plus 4, which will give us 12. And on the bottom, we will have 10 plus 6 plus 8, which will give us 24, which again, 12 over 24, that simplifies to 1/2. Okay. So you should notice that all of those were the same. Okay. Now, area is going to be a little bit different. So area of a triangle, remember when we do the area of a triangle, we use 1/2 times the base, our base and our times the height. Our base and height need to be touching our 90-degree angle. So my base is going to be 3 and my height is going to be 4. Okay? And that is because they were both touching that 90-degree angle. Okay? The hypotenuse is not a part of it. Okay. Going back to the area of the larger triangle, 1/2. My base is 6 and my height is 8. Okay, let's go ahead and multiply that out. That will give me 1/2 times 3 times 4 will give me 6, and then 1/2 times 6 times 8, that'll give me 24, and then we can simplify 6 over 24 to 1/4. Okay, so if you notice, and that's super important, okay, this one is different. Okay, so how do all of our values compare? You should see that all of the green ones, those were the same, but area was different. Okay. So ratios are the same except for area. Okay. So now we're going to talk about our different theorems. Okay. So when we are doing ratios, we start with our similarity ratio. So this is going to be comparing whatever those side lengths are. If we have A over B, okay, then we can know our perimeter is going to be the same based off of our warm-up. So it would still be A over B. Now this is where things change a little bit. When we are talking about the area ratio, we have those, but similar to how our units are squared, we're going to square our values. So if it's A over B, we're going to square that. Okay. And remember, if we want to square a fraction, that's the same thing as taking A to the second power over B to the second power. Or A times A over B times B. So we just multiply it by itself. Okay. So let's jump in with an example. Okay. So example 1, given that triangle LMN is similar to triangle QRS, what is the similarity ratio? Okay, so the similarity ratio is when we compare our sides. So we already know that they're similar, so we only have to do this for one side. So let's pick a side. I'm going to choose LM to be my side. So LM is 13. And side 2, what is related to LM? Well, LM is my first two letters, so my second two letters are QR. QR is going to be 9.1. Okay. Now we're going to take those to the ratio. Okay, the ratio is going to be LM over QR, which is 13 over 9. Oops. 9.1. Okay, and then if we go ahead and divide that one out, it's going to give us 1.43. Okay, hopefully you double checked my math with that one. Okay, now we know with our perimeter ratio, those should be the same. Okay, so I'm going to put my ratio as 1.43, and then I'm going to go ahead and check my work. Okay, so the perimeter, or I'm going to use that to check my work. So the perimeter of my first triangle is given to me right here. It's 36 centimeters. So 36. Okay. In the second one, we don't know what the perimeter is, so that's what we're going to have to find. Okay. So I'm going to mark this as X. Okay. Now to solve this, we're going to go off to the side, okay, and we're going to use our ratio. We're going to use the same ratio as before because we know they should be the same. Okay, so we're going to take our LM over QR, or 13 over 9.1, and we're going to set it equal to my new ratio, so 36 over X, and we're going to solve for X. So to solve for X, we're going to do our extremes times our means, which will get us 13x equals 32. 327.6. And we're going to divide by 13. And x will end up being 25.2. Okay. So then that's going to give us our x. So let's go ahead and fill that in. 25.2. And our units will be centimeters. I'm going to go ahead and fill that in at the top as well because I forgot to put my units. Okay. Now, when we do the area, it's going to work a little bit differently. Okay. So we know the ratio is going to use that same number. It's that 14.3. However, we need to make sure that those numbers are squared. So we're going to use the 13 over 9.1, and we're going to square those numbers. times 82.81. And then go ahead and multiply those. Will give me 4968.6. We're going to go ahead and solve by dividing by 169. X is going to be 29.4. So let's go ahead and fill that in as my area. And using this, we found all of those different missing parts. Okay. So the important part to note was that we used our ratio, and then for the area, we had to square it. Okay, that was the newest part of this. Let's try another example. If triangle ABC is similar to triangle DEF, the perimeter of DEF is 54 inches, and the area of triangle DEF is 126 inches squared. AB is 6.5 inches, and DE is 13 inches. So we're going to use that information. I'm going to take that and label it on my pictures, just like it was already labeled for me before. So I'm going to use the perimeter of DEF is 54 inches, and the area is 126 inches squared. Okay, let's go ahead and label our sides. AB is 6.5 inches, and DE is 13 inches. Okay. So now we're ready to go ahead and go through those same steps. So the first thing we need to do is find our similarity ratio. So similarity ratio is when I compare the sides. So side 1 is 6.5. Side 2 is 13. We're going to do 6.5 over 13, okay, which is going to simplify to 1 over 2, or 0.5. Okay, so I know that this is my ratio as we continue. Okay, so my perimeter ratio, remember perimeter is the same, it's going to be 1 over 2, or 0.5. So when I do the perimeter, we're going to use our first triangle perimeter, which we don't know yet. So let's do x over, our new perimeter is 54, and that needs to equal the same ratio, so 1 over 2. So let's go ahead and multiply our extremes and means. 2x is going to equal 1 times 54. And then we're going to divide by 2. X is 27. So my first triangle is going to have a 27 inch parameter, and the second one was 54, because that was given to me. Now, area ratio, remember this is the one where it changes. Okay, I need the one area, so the area of the second triangle is 126 inches squared, and we're going to use that to find the other one. However, my area ratio, I'm going to take that 1/2, and I'm going to square it so that it is 1 over 4, or 0.25. Okay, so I'm going to use that 1 over 4. And x over 126 is going to be 1 over 4. Multiply my extremes and means. divide by 4. My area of that first triangle is going to be 31.5. Make sure you're checking my math on all of these, just in case. And again, that's inches squared. Okay, and make sure you've answered all the questions. I don't see any more blanks, so we should be good to go. Okay, so for your student practice problems, you have 2 of them. Make sure you're filling in all of the blanks, and you're trying to find the similarity ratio, perimeter ratio, and then area ratio. So all of those.